Okay, so now let's do the next question. Find y of t if x of t is equal to t into u of t and h of t is equal to u of t minus 2 using convolution theorem of Laplace. Okay, so here given the input signal is t into u of t, right? And the impulse response is u of t minus 2. Okay, so we know that y of t is equal to x of t convolution with h of t. So taking Laplace transform on both sides, it will become y of s is equal to x of s into h of s. Convolution time domain becomes multiplication frequency domain. So simply find the frequency domain of x of t and frequency domain of h of t and then multiply the two answers and then find the inverse of y of s. That's how we find y of t. So here x of s is equal to the Laplace transform of x of t, which is the Laplace transform of t into u of t, which is equal to 1 by s square. Okay, and h of s is the Laplace transform of h of t, which is the Laplace transform of u of t minus 2. Laplace transform of u of t minus 2. So what is the Laplace transform of u of t minus 2? We know that the Laplace transform of u of t is equal to 1 by s, right? So according to time shifting theorem, the Laplace transform of u of t minus 2 is nothing but e raised to minus 2s by s. You see, Laplace transform of u of t minus 2, time shifting theorem. So if there's a time shift in the time domain, then there will be an exponential function multiplied in the s domain. Okay, so that means the Laplace transform of u of t minus 2 is equal to e raised to minus 2s by s. Okay, so therefore the y of s is equal to x of s is 1 by s square into h of s is e raised to minus 2s by s, which is equal to e raised to minus 2s by s cube. This is the Laplace transform of your answer. So therefore, to find your answer y of t, you have to find its inverse. That's all. That is, y of t is equal to Laplace inverse of y of s, which is the Laplace inverse of e raised to minus 2s by s cube. Right? So this is how we find. So now, how to find the Laplace inverse of this? To find the Laplace inverse of this, you have to find the Laplace inverse of 1 by s cube, because this e raised to minus 2s means that your time domain is being shifted by minus 2 seconds. So that means all you need to do is replace every t with t minus 2. Replace every t with t minus 2. So that is, this means that you need to find the Laplace inverse of 1 by s cube and then replace every t in that equation with t minus 2. That's the meaning of this. Okay, so what is the Laplace inverse of 1 by s cube, or how will we find the Laplace inverse of 1 by s cube? If you know the answer, you can write the answer directly, or suppose if you have difficulty in understanding how to find it, just simply remember this. That is, Laplace transform of u of t is nothing but 1 by s. We all know this, right? We all know this. So now if I multiply this with t, if I apply multiplication by t theorem or frequency differentiation theorem, what will happen? So this will become Laplace transform of t into u of t, right? Laplace transform of t into u of t is nothing but minus of d by ds of your previous answer, that is 1 by s. Or this is nothing but minus of minus 1 minus of minus by minus 1 by s square. So it will become 1 by s square. This will become plus 1 by s square. Likewise, the Laplace transform of t square into u of t is nothing but, so again I am multiplying this. So again to multiply this with t, then I have to differentiate this one, right? So that is minus d by ds of 1 by s square, which is nothing but, this is nothing but minus of minus 2, so because plus 2 by s cube, right? So that means the Laplace transform of t square u of t, the Laplace transform of t square u of t is nothing but 2 by s cube, or in other words, the t square by 2 u of t is the Laplace inverse of 1 by s cube, right? So the Laplace inverse of 1 by s cube is t square by 2 into u of t. See, this is how we find. Anytime, whenever you see 1 by s or 1 by s square or 1 by s cube, simply remember this method of finding the inverse. Okay, so it will become very easy for you. So here I found the answer, that is y of t is nothing but, let me write it again, y of t, therefore y of t is equal to the Laplace inverse of 1 by s cube, where t becomes t minus 2, or in other words 1 by s cube, Laplace inverse of 1 by s cube is t square by 2 u of t, when t becomes t minus 2. Okay, or in other words, it's nothing but t minus 2 the whole square by 2 into u of t minus 2. So this is your answer. Okay, where did this t minus 2 comes from? Because the Laplace transform of y of s is e raised to minus 2s by 1 by s cube. We have already found the Laplace inverse of 1 by s cube. So if you are going to multiply 1 by s cube with e raised to minus 2s, then you have to time shift the time domain function by 2 seconds. That is why t becomes t minus 2. So every t that you see here becomes t minus 2. Okay. Now for the next question. If x1 of t is equal to t into u of t, which is also equal to x2 of t, that means x1 of t and x2 of t are both equal to t into u of t, then find y of t, where y of t is the convolution of x1 of t and x2 of t. Okay, so that means, this means that given y of t is equal to x1 of t convolution with x2 of t. Okay, so that means y of s, if you are applying Laplace transform to the above equation, y of s is x1 of s into x2 of s, right? So what is x1 of s? What is x1 of t? x1 of t is equal to t into u of t. Therefore therefore x1 of s is equal to the Laplace transform of t into u of t, which is equal to 1 by s square. Therefore x2 of s is also equal to 1 by s square, which means that y of s is equal to 1 by s square into 1 by s square, which is equal to 1 by s raised to 4. Equal to 1 by s raised to 4. Okay, so now to find y of t, how to find the value of y of t? Y of t is nothing but the Laplace inverse of 1 by s raised to 4. Okay, so here maybe you can just pause it and try to find the Laplace inverse of 1 by s raised to 4 by yourself. It will be very good for your practice. Okay, so how do you find the Laplace inverse of 1 by s raised to 4? Right, like I said before, we know that the Laplace inverse of u of t is equal to 1 by s. Therefore the Laplace transform of t into u of t, as per the frequency differentiation theorem or multiplication by t theorem, Laplace of t into u of t is nothing but minus of d by ds of 1 by s, which is equal to 1 by s square. Likewise, the Laplace transform of t into u of t or t square u of t is nothing but differentiation of this answer minus differentiation of this answer, that is minus d by ds of 1 by s square. Okay, which is nothing but, this will become minus of minus 2 by s cube, which will become 2 by s cube. Okay, so now if I want to find the Laplace transform of t into t of u of t means then I have to minus differentiation of this answer. That's all. So this will Laplace transform t cube u of t is nothing but minus of d by ds of 2 by s cube. So which is nothing but here it will become minus 2 into minus 3 by s raised to 4, which is equal to 6 by s raised to 4, right? So that means the Laplace transform of, therefore that means the Laplace transform of t cube u of t is equal to 6 by s raised to 4, or the Laplace transform of, if let me put the 6 inside, it will be t cube by 6 u of t is equal to 1 by s raised to 4, or in other words the Laplace inverse of 1 by s raised to 4 is nothing but t cube by 6 u of t. Therefore I could say that y of t is equal to the Laplace inverse of 1 by s raised to 4, which is nothing but t cube by 3 u of t, I mean by 6, t cube by 6 into u of t. That's the equation for y of t. Okay.